Hello everyone, welcome to today's webinar for the Women in Technology virtual group. I'm Kathy Kellenberger, co-leader of the group, and our group typically hosts one webinar per month by a woman in our community. I love this because presenting is a great way to enhance your career. Whoops. You can find all the recordings from our meetings on YouTube. Please check out our homepage where you can find lots of information about what's going on with the chapter, with women presenting for us, other chapters, and SQL Saturdays. And if you're not already a member, please join our virtual group. And you can also follow us on Twitter. Past virtual groups would not be possible without the generosity of some wonderful sponsors. We have two sponsors, believe it or not. SentryOne has been a sponsor for several years, and they also sponsor the WIT Luncheon at Past Summit. A little over a year ago, Redgate Software also became a sponsor. As part of the funds they provide, we are able to award gift cards to a lucky winner each month. If you are the winner, I'll send you an email letting you know after the session. The sponsors do get some benefits for providing funds for the virtual chapters. And one of the benefits is giving a short introduction during one webinar each year. Excuse me. Today, Redgate wants to tell us about how they support the community. And I actually work for Redgate, so I'll start out and then I'll hand it over to my colleague, Rosanna, in a couple of minutes. Learning and sharing is at the heart of Redgate. We're committed to supporting the community and helping them to solve problems, share ideas, develop their knowledge and skills. And we do this through the Redgate Hub, sponsorship of user group and events, which is amazing, and our Friends of Redgate program. The Redgate Hub has got something for everyone, and it's the go-to place for sharing ideas, solving problems, and getting the most from your Redgate products. Inside the Redgate Hub, you can find product learning articles with tips and how-to guides for Redgate products, as well as Redgate University, which is a series of self-paced online training courses with easy-to-follow classes. And I actually took a couple of these over the weekend, and they're pretty good. Topical articles and opinion pieces from SimpleTalk. And SimpleTalk articles are not about Redgate products. For example, there are articles covering the basics about SQL Server and all the way to the latest Azure capabilities. My role at Redgate is the editor of SimpleTalk. So if any of you are interested in writing articles for SimpleTalk, you can contact me at editor@simple-talk.com and be sure to include that you heard about this opportunity from today's session. We also have forums where you can discuss and solve questions about Redgate's tools, and many events, a really large number of events, free webinars, SQL in the City. There's a lot of information that you can find out from these webinars, just about things like DevOps, for example. We are in person at a lot of events, and we sponsor quite a few user group meetings as well. And at least in my experience, Redgate has sponsored every user group where I've attended this year, or not attended, but presented, I should say. And I visited at least 10 user groups this year to talk about topics like machine learning, indexing, windowing function, execution plans, and Redgate has sponsored me each time. Not really sponsored me, but sponsored the meeting. We also have our wonderful Friends of Redgate program, and at this time, I'd like to introduce my colleague, Rosanna Whiteleg, who is the director of the Friends of Redgate program. So, Rosanna.
Thank you, Kathy, and hello, everyone. I'm here today to tell you a little bit more about the Friends of Redgate program. So a big part of our work in the community is with our Friends of Redgate. For over 19 years, the Friends have been an extended part of the Redgate team, helping us to support the Microsoft Data Platform community, develop even better software for our users, and reach more data professionals across the world. Now, our friends are all experts on the Microsoft Data Platform and are influential and active in the community. They know Redgate and our tools and have clear ideas and opinions about the technology they work with. I thought I'd introduce you to some of the class of 2018. There's just a few faces there. I'm sure some of them are familiar to you. Now, rather excitingly, this month we're opening applications for the 2019 Friends of Redgate programme, and would love to hear from members of the Women in Technology virtual group. And I just thought I'd just take this few moments just to explain about what you can expect from the programme. So we see the Friends of Redgate as an extension of our team and collaborate with them on activities that support the learning and development of the community. Now, there are a range of different activities that you can work with us on, so you can find the ones that most suit you. Examples include writing product learning articles for the Redgate Hub and topical articles for SimpleTalk, as Kathy mentioned earlier, and this, as shown in the examples on the screen. So Catherine and Annette, who are both Friends of Redgate, have worked with us this year to write articles. We will also work with you to present sessions to the community, both in person at user groups and events, such as SQL Saturdays or Redgate Summits, and virtually via our free online events programme. This year, a number of our friends have presented at the Equalness City Summit. So that's Brian on the left there presenting for us, and they've also hosted webinars with us. Another way that we'll work with you is to build and develop our tools. So we'll connect you with our development team so you can share your insights and ideas on how to make our tools deliver even more value to our users. And we'll also work with you to help the community to solve problems. So we'll work with you on the Redgate forums and are helping to answer all those tricky questions that the community is facing. Now, in addition to all of this, you will get free licenses for Redgate tools, invites to exclusive gatherings and events such as the annual Friends of Redgate dinner at Par Summit, which is the picture you're seeing right now on the right, so we can get to know you a bit better and thank you for being part of the programme. You'll also get learning and development opportunities. So we'll help you to develop your skills such as presenting and writing, and we'll teach you more about our tools and our DevOps solutions. We'll also support, and you'll also receive our support and guidance. So as I mentioned earlier, our friends are an extension of the Redgate team and we'll help and support you in any way that we can. And you'll also receive insider info on what's happening at Redgate and news of our latest releases via a monthly newsletter, a private forum, and a closed Twitter group. Now, I thought I'd give you a little bit more of an insight into the programme. So I'm going to share this quote from one of our long-standing friends of Redgate, Chris Yates. And now Chris has said about the programme, "The first time I experienced SQL Family was with Redgate. They're very community focused. The programme is a collaboration area between Redgaters and friends. I've made lifelong friends and I've gained an insight into the tools, which has been extremely beneficial." Now, if you like what you hear and you think you'd make a great friend of Redgate, then we'd love to hear from you. Applications for the 2019 programme open on Monday, and they are open for about a month because we realise that you're probably busy with all sorts of Christmassy things at the moment. So they're open until Monday, the 14th of January. So if you're interested, please do email me with any questions on friends@red-gate.com, to request an application form or to ask any questions, and I'll be very happy to help. Finally, you can learn more about Redgate in the community and the Friends of Redgate programme, so everything that Kathy and I have discussed today on the Redgate Hub, and there's a link there. So it's www.red-gate.com/hub. Thank you, and I hope you enjoy Sabnam's webinar.
Thanks, Rosanna. Now back to our webinar. So we always, excuse me just a minute. Before I hand it over to our speaker, I'd like to call out the women speaking at SQL Saturdays this weekend. There's a SQL Saturday in Slovenia and Washington, D.C. If you're going to either of these, be sure to check out the sessions by these fantastic speakers. There are also several webinars come up, and we promote any webinars of the past virtual groups that are presented by women. So you'll see a lot of them that are not our group. Our next webinar is December 19th by Julie Smith, and I encourage you to attend any of these that you're interested, and you can find the links to register on our website or in the newsletter. Today's session is Performance Monitoring of Analysis Services Tabular by Shabnam Watson. You'll learn how SSAS Tabular uses system resources and how to monitor the performance. She'll have demos showing how to use extended events, perfmon, DMVs to collect the information and find those performance problems, and how to build a Power BI dashboard using this information. Shabnam is a business intelligence consultant. She has 15 years of experience developing data warehouse and business intelligence solutions. Her work focus within the Microsoft BI stack has been on SQL Server analysis services, starting with SQL Server 7. That's a long time ago. She has helped many companies with their analysis services design and implementations, as well as performance tuning queries and analysis services servers. She holds a master's degree in computer science and a certified business intelligence professional certification by the Data Warehouse Institute. And she's spoken at Past Summit, SQL Saturdays, Women in Technology Virtual Group, Atlanta MDF, and Atlanta BI SQL Server user groups. So before I hand it over to Shabnam, please, if you have any questions during this session, just type them in the question box on the GoToWebinar application, and we'll answer those as we go. I'll answer a couple of questions right up front. Yes, we will be posting the video on YouTube, and I don't know the answer to the next one, whether she'll have her code samples out there. If people want the code samples, I'll get those from her and we can post them as well on our sites. So I'm going to go ahead and unmute her and make her the presenter. All right, so you can take it away when you're ready.
Okay, do you see my screen?
I do.
Okay, thank you, Kathy, for the introduction. Hello, everyone. This is Shabnam Watson. Thank you for joining us. As Kathy mentioned, I have worked with analysis services for a long time now, since 2002. I started as a .NET developer working on an application that generated dynamic MDX queries based on the user selection, sort of like what you have in Excel or any other front-end tool. Then I gradually moved to a full BI role over the years, focusing on designing analysis services databases. And for the last several years, I've been interested on the server side of analysis services on performance monitoring and see what happens on the server side. And that's what I'm going to be talking to you today. So who is this session for? This session is for someone who's already familiar with analysis services and wants to look at it from the server side, understand some of the metrics that are important for its performance. And the takeaways of this session, my goal is for you to learn a couple of things for you to be able to go log into analysis services box and tell right away whether the analysis services is under memory pressure or CPU pressure, and how to, once you know what to look for, how to store them for long-term use. So there is no actual development data modeling of analysis services or Power BI in this session, although I will show you some Power BI reports that I've built. So this is the agenda. We're going to look at several tools that come free out of the box with Windows and SQL Server. We're going to look at Windows perfmon, extended events from analysis services, and dynamic management views. Each one of these will provide us with different information about analysis services. We're going to pull all of that into a SQL Server database, and then from there, I will build a Power BI dashboard. So the goal is to get to that dashboard screen that you see at the end, where you can see for the past 15 minutes what's been going on with your server in terms of memory, connections, sessions, the price of the memory at the moment, the CPU consumption. So before we get there, I'm going to go through some concepts for you to understand why we're going to measure the things that we're going to measure. So why monitor performance in the first place? Analysis services is a great product. In most cases, it works out of the box without you having to change any of the settings. But when you have one or more of the following. You have a large user base that are querying concurrently. You have low resources, so you don't have enough CPU or physical RAM. Or you have developers that have not followed best practices, so they've sent models that are taking more memory than what they should. You have bad calculations. All of those in combination, they can create problems on the server. So in such scenarios, you need to keep an eye to figure out what's going on. So you need to monitor both analysis services and the server, the machine that it's on, together to get an idea, because sometimes the problem can be from the machine itself. You need to look at a point in time, which is what's going on now, and be able to compare that to what's normal for your server. Some of the metrics have very set values where I can tell you if you see this number, you know you're in a bad state, but a lot of them are going to depend on your environment. And the way to get to what's normal for you is to keep benchmarks and some history also to know what has happened in the past 15 minutes or an hour on a server. So for example, I ran into this scenario where I would get calls from users and they would say, hey, we can't connect to the server. Can you go check the server? I remote log in. I can connect. The server's running. I check the CPU. There's not much CPU going on. I check the memory. It normally takes about 60 gigs or so on this particular box. The memory consumption is at 15 gigs. So everything checks out. User queries are flowing. No problem whatsoever. So what were those people talking about? Obviously, something had happened in this case, and I didn't know what it was at the time, and I'm going to show you an example of this. Something had happened, but analysis services had recovered within those span of 10 to 15 minutes. So when I looked at it, it was in a good state, and because I didn't have a way of looking back in time to see what had happened, I had no way of figuring out what was going on. So with that said, let's look at analysis services, get over a couple of concepts. Analysis services runs as a Windows process. This means that if you go to Task Manager, you open up Resource Monitor, you can see it as one of the processes that are running. So in this screenshot, I am showing you MSMDSRV, which is the name of the analysis services process. So as a process, analysis services request resources from Windows. And when it requests resources from Windows, then Windows, the operating system, decides what to give to it. So under the CPU, if you got only one tool to use, you can use Task Manager to figure out how much pressure is on your analysis services. If you go to Task Manager and the CPU of the process is constantly sitting at 80% to 90% and it never comes down, then you have a problem there. Then you need to look into and see what's causing that. Now, if you look at the memory tab will tell you under the commit kilobyte column, it will tell you how much memory analysis services is using. So this is how much memory the operating system has provided to analysis services. So our goal is to track that number along with how much memory the box has left together. Okay, so what you see below where it says how much memory is available, we're going to track that, and we're going to track this commit kilobyte size in our reports. Now, if you know what the limits for your analysis services memory are supposed to be, which we're going to talk about those, if you open up Task Manager and you look at just that commit kilobyte size number, you should be able to tell whether there's memory pressure or not. So if you got nothing else, Task Manager is your friend. You can kind of tell what's going on at a point in time as a snapshot. Okay, so analysis services consumes memory for the databases that's storing in memory. So we're talking about Tabular in particular. So all of the databases are stored in memory. And Then the queries come in. The queries also require memory. So as it's answering queries, there are caches that it uses to answer queries. And then it uses memory for sessions and connections and other metadata, right? When queries come in, so talk about the queries first. When queries come into analysis services, they hit the part that's called formula engine. And this architecture has been inherited from the multidimensional. So this part is the same with multidimensional if you've ever worked with that. The formula engine has a cache. If a query result set is already in the cache, it can answer it right away. So this is the fastest possible way for a query to be answered. If the answer is not there, the formula engine breaks it up into several dataset requests and sends it in parallel to the storage engine. Now, the storage engine for Tabular is either Vertipack, which is an in-memory columnar storage system, or it's Direct Query. In Direct Query, your queries are going to go back to your source, your SQL source. So nothing's actually, the data is not actually stored in analysis services. We're not going to talk about that. We're going to focus on Vertipack today. So Vertipack stores your data column by column, compressed. And it has its own cache. So when I first saw this graph, I couldn't understand why is there a cache. If Vertipack is in memory already, what's the cache for? Well, the answer is on this slide. The storage engine cache stores the information uncompressed. So in order to get from the compressed data to the uncompressed state before it gets passed up to the formula engine, you have to spend CPU cycles and time. So what's in the cache is uncompressed. What's in the Vertipack is actually compressed. So that's the second fastest way for a query to be answered. And if your data structures do not fit in memory, so if the Vertipack does not fit into memory, it is allowed to page to disk. So there's a page file disk, there's a page file sys file that Windows provides to provide virtual memory to processes. And Tabular is allowed to use it. Now, it's there to help you with scenarios where you don't have enough memory on a box because you're on a dev box, or maybe potentially during processing times when the memory requirement doubles and triples. But other than that, you don't really want to see that page file being used constantly because performance will suffer when that happens. Okay, so analysis services uses memory to answer queries for its data structures and sessions and everything else. How is this memory controlled? If you go to your instance and you go to Management Studio and get the properties, you will see that there are certain limits under the memory section listed. There's a low limit, a total, or also high limit. You're going to hear me talk about the high limit, I mean the total, and then the hard limit. What these are percentages of the total amount of RAM on the box that analysis services is going to work with, and we're going to explain what these are. So the low limit on a box that has 100 gigs is set to 65 gig. The total is 80 gigs. And the hard limit when it says 0 is halfway between 80 and the maximum. So in this case, it's going to be 90 gigs. All right. So analysis services is going to work with these limits and decide how to adjust its memory, okay, which I'm going to show you in the next slide. All of these are available for you to look at from Perfmon. So in Management Studio, you see the percentages. If it's over 100, it actually turns into bytes, so you can see the actual bytes. But if it's under 100, it's percentages. If you go to Perfmon and look at those counters, you're going to see the actual values. You can also see a counter called memory usage kilobyte. This memory usage kilobyte shows you how much memory analysis services is approximately using. Now, I say approximately because I'm going to give you more detail about it in a little bit. So knowing this, let's talk about how analysis services adjusts its memory. Analysis services uses an economy model for managing its memory. It means that at first, when there's nobody in memory, as data sets come in, they can stay as long as they want. It's free to stay. Once it hits a point, then there is a price to stay in memory. If you got money to pay, you get to stay. If you're out of money, you leave. Every time you answer a query, you earn money. Every time an L services checks with you, you pay money, you pay tax. So it's kind of like a money-based example. And so here on this graph, I'm looking at a box that has 100 gigs of memory. And my limits are 65, 80, and 90 on the left axis. On the right-hand side, I have the price per kilobyte. This price per kilobyte also you can see from Perfmon. It's very interesting because that's one of the counters that its value is always between 0 and 1,000, regardless of what machine you're on. So those numbers are transferable. So as memory increases, so more people come in, more queries come in. Once analysis services memory reaches 65, that's when a cleaner thread wakes up, and you see the price of memory jump from 0 to 2. Then as memory increases from 65 to halfway between 65 and 80, the price of memory slowly goes up. So at this point, the cleaner is trying its best to throw some things out. And let's say the pressure on the box continues. At this point, the price of memory is 10. Next, from the halfway point to the high limit or total limit, the price of memory jumps all of a sudden from 10 to 1,000. The more the price, the more aggressive the cleaner is. So anything that's not pinned down is trying to throw out. But remember, it cannot throw out certain things. So it cannot throw out the current queries, and it cannot throw out the VertiPack data, your database structures that are in memory. It cannot throw them out. So certain things are staying and the pressure on memory is increasing. Now, if in spite of everything it's doing for various reasons, the memory consumption goes higher, then you reach this hard memory limit, at which point it will drop out and will close all connections. That's when you get the call from the user to say, hey, we got disconnected. So when in the example that I gave you, when I was looking at the box, I was looking at it where it was recovering back here. So it was coming back up, and there was no crash report because it had not crashed, right? So this is how NL services manages the memory at a high level, right? So the Perfmon counters that you can follow are memory usage kilobyte and memory current price. Now, just when you think you understand this, Tabular makes it a little bit more complex. So we got 2 more settings. The VertiPack paging policy, by default, it's 1. If it is set to 0, that means no paging is allowed. So if the amount of your database's memory goes above the physical RAM, it will just give an error. So if you have a database and you start processing it and your VertiPack data structures take more than what's available in RAM, it will error out. So no paging allowed at all. But when it's set to 1, that's when paging is allowed. This is the default value. And then this other limit, VertiPack memory limit, comes into play. So this limit is a bit difficult to understand. I'm going to try to explain the best I can. The best way for you to understand this is on a dev box to go and play with this number and bring it up and down and see what happens. So remember I said memory usage kilobyte shows the amount of memory that NL service is using. Well, that's not entirely true. It is capped. So it only includes the VertiPack data up to the limit. The actual memory that it's being used by NL services that you can see in Task Manager under the commit kilobyte is available from a different counter called process, filtered to MSMD SRV under private bytes. So these 2 follow closely, but sometimes they can separate, and that's that can indicate some memory problems that I'll show you. So for example, if you got 5 gigs of base memory and your VertiPack data is taking 70 gigs, the memory usage kilobyte is only going to show 65, which is only 60 of the 70 is being included for the purpose of calculating the current price of memory, okay? So back to the same graph, but this time on the y-axis, I have virtual memory. So the box still has 100, but now we can go up to 150 because we can page to disk. Now I'm graphing the private bytes, what you see in Task Manager. So let's see the amount of the base memory for analysis services is about 5 gig. And the memory consumption goes up. We hit the low limit. Does the cleaner wake up? Well, let's see. So let's say we hit 150 gigs. At this point, the VertiPack memory is taking 150 minus 5. So let's say these aren't queries, these aren't sessions, it's just 145 gigs of VertiPack memory. At this point, what the cleaner sees is only 5 plus 60. So no matter how much your VertiPack memory goes up, the cleaner always sees that limit, the 60. Now, if you're graphing the process private bytes, you're going to see that you actually went above the limit. But if you're paying attention only to the price, what the cleaner sees is that lower line, is this blue line. And as far as the cleaner is concerned, things aren't that bad. So in a case like this, you have to pay attention to how much the memory is paging because you're going to see heavy paging. Now, these are all kind of exaggerations of things that can happen when the box doesn't have enough memory or when you have super large databases. Okay. So just to summarize, the perf counters that I like to work with are these. The limits. So we have the limits. We have the memory that's available to that the cleaner sees, things that the analysis service is using. Then there are 2 counters called VertiPack page kilobyte and VertiPack non-page kilobyte. Together, they show you how much VertiPack data is used by analysis services. The word page does not mean that it's been paged to disk. It means that it's pageable. So just think of these 2 as the VertiPack memory consumption. And then this is where you can get the actual number that you see in Task Manager as far as memory usage. Cleaner current price, and then the other ones we talked about are the memory pages per second, available megabytes. And then you have things such as CPU consumption. You can get the processor, which is the actual machine's CPU usage under the processor category. Analysis services processor usage, you have to get it from the process category. You're going to see in Perfmon, these are different categories. And then you can get information from storage engine, from connections. These are useful to know, for example, if you usually have 400 users on a box and you log in and you see 10 users and it's in the middle of the day, that's a red flag. So these are the things where you need to have benchmark for you to know what's normal for these counters versus for something like price of memory is always between 0 and 1,000. Okay, so I'm going to switch to demo. See if I can bring up my analysis services. All right. So first of all, if I go to Task Manager and I open Resource Monitor, I filtered here to MSMD SRV. And you can see that, by the way, I have 2 of them listed. Let me go back to the CPU tab. I have 2 of these listed because the second one is my Power BI desktop that I have running down here. So the way I know which one's which is by using the process ID. Only the analysis services server is showing under the services section, right? And if I go to the memory, I can see both of them actually. So I can see that analysis services right now is using 1.7 gigs of RAM. right? And so, by the way, if you've ever worked with Power BI, you have worked with analysis services, you just didn't know you were using it, but it is back, it is there. All right, so I'm gonna go to Management Studio, and this is my server. I'm gonna look at the properties and show you where the memory settings are. So here at the bottom, you see the limits. Now, they're by default set to 0, 65, 80, and 60. However, here I have intentionally set them to lower limits so that we can run a test and put some pressure on a box, because if I run it with the full amount of memory, it will take longer for me to show you what I want to show you. So I'm going to cancel out of here. And just a quick explanation of my databases. So I have AdventureWorks. I also have this database called Chicago 311. This database contains service requests from City of Chicago. I built this database off of a public data set that's available from Kaggle. And I just brought in 5 tables that are completely independent of each other. So garbage cars, graffiti, potholes, rodent baitings, and streetlights. These are requests that people have sent to the city for the city to come and fix a problem. So each one has 1 row for each service request. This was a good database for me because a lot of the columns cannot be compressed. As a result, this database is taking about 280 megs. Okay, so if I run a simple DAX here, you're going to see my row counts. So I have 1 million in the first row, and then anywhere from 500,000 to 300,000 in each one of these. Okay, so this is my database, and now let's go take a look at the perfmon and look at perfmon. Now perfmon, there's 2 ways you can get to it. You can go to search, run, and then just run perfmon, type perfmon.exe, and Windows Performance Monitor comes up. But instead of opening it that way, you should open it by running MMC. So search for mmc.exe. Okay, when you run mmc.exe, you get this console, and then you go to File, Add, Remove, Snap-in, and you get a list of snap-ins that you can add. So these are all things you've probably seen, like computer management, event viewer, SQL Server configuration manager. One of the choices is Performance Monitor. You add it here, and you get to Performance Monitor this way. Now, why do I like to open it this way? Because once I have a list of counters, I can go to File, and I can save it, and next time I can just open it. So you can see that I have these built here. I can just say open. I'm not going to do it right now. We're going to build something together. But once you have a list saved, you can take it to other servers as well. All right, so I'm going to change the view to report and then add a couple of counters here. By default, this list opens on the processor. And from the processor category, I only want to take processor time, which will give me the CPU. The next category is process. Now, under the process, you can filter to one process, particular process. I'm going to go to MSMD SRV, which is this one. That's my Power BI. And from the group, I don't want to take the whole thing. I want to take processor time, and I want to take, at the very end of it, I want to take the private bytes. This is the commit size from Task Manager. Okay, and if I scroll up, I have all sorts of counters from Windows available. These are for SQL Server 2019, and these are for analysis services. So analysis services default instant counters are going to show up under MSAS, a number, and the category. So I'm working with 2017, that's why it says 14 in there. If you're working with 2016, you're going to see 13 in there. If I go under the memory, you see all these counters that we talked about, they're all here. So current cleaner price, and then from here, I want to pull the limits and the memory usage. And towards the end, the Vertipack usage, right? I'll say OK, and I see all of the values. So I can see right now that the memory usage is 1.7. The price of memory is 0 because 1.7 gigs is less than 2.4 gigs, right? So this is great. I can look at it, but how do I save this somewhere, right? The answer is data collector sets. So you can use data collector sets to have a set of counters saved over time. So I'm going to create one, and you can run these based on certain schedules. So I'm going to call it test, and I can create this manually or from a template. If I do manually, it's going to bring up the same interface as we saw before, but I'm going to create it from a template that I've created, which has the exact same set of counters that I just showed you. Now, by default, it saves the results into this system drive, the system path. Okay, so now I got my data collector, and if I get the properties, you're going to see that I have my counters, and the format by default is binary. I have changes to comma separated, okay? Now I'm going to let this run, so I'm going to let this run, and while that's running, so now it's recording, I'm going to run this little simple DAX, and then I'm going to run this query that I call the bad practice DAX, because what it's doing is it's doing something completely nonsense. It's taking the service request numbers from each one of those tables and doing a cross join of all of them. So 1 million by 500,000 by 300,000, so on and so forth. And then it's doing a group by on it to get a distinct list and then returning the count. So it's doing something very heavy. So I'm going to run this, and we're going to go back to here, actually here. Look at the price of memory. Look at the memory that's climbing, right? And then keep an eye on the cleaner current price. See, I went to, it's going up, and it's going to climb up very soon to 1,000. And as soon as this goes past the hard, NL services is going to kill the query. And it comes down. So now if I go back to my query, it says, sorry, there wasn't enough memory. Try again. Maybe there will be more memory, right? So if you're just using perfmon, point in place, you may miss that, obviously. But let's go and see what our file did. So I'm going to go to where the file is being saved. And now I have a CSV file there. Okay, so let's see what happens if we graph this. I'm going to graph these columns, go to Insert, and let's take a look. See, now we have a nice graph that tells us what happened, how the memory usage climbed up, reached the hard limit, and then lost all its memory. So now I can go also, if I go here, and format data series, send the price to the second axis, you can see how the price of memory went up to 1,000 and got down. Okay, so this is great. Obviously, if you got a machine you're just monitoring for a day or so, this is fine. You can let these run and you open up the Excel file, you can do the graphs and analyze and all that. But over time, this is not maintainable. So over time, you want to have something that wakes up every month, records for a little bit for you to have benchmarks. So how do we get this to write to a SQL database? So I'm going to stop this. And we're going to take a look at the properties. Okay, so the format is comma separated, but I can also change it to SQL. Now, the moment I change this to SQL, I get this data source name enabled. If I expand this, you're going to see I have a list of data sources available, right? So how do I get this data sources to populate? The answer is by using ODBC data connector. So again, in Windows, if you just type ODBC data source administrator, it's going to come up. You want to go to System DSN, and click on Add. I'm just going to show you the configs for the one I already have. It's the exact same interface. So you type in, you give it a name, you give it a name of a server, that's my server, and you want to change the default database to whatever database you want to write to. So right now I have a SQL database called test that I'm going to write to. And that's about it from here, okay? So once I have that data source name, I can choose here to write to it. And one more thing I need to do before I can actually write is to go on the set itself. So notice how you get different properties if you right-click on the set versus the data collector itself. On the set, you need to change this run as from system to an account that has access to your SQL Server database. So you need to have permissions to write to it and create tables. Okay, click OK. Before I run this, let's go take a look at that SQL database. So this is my local SQL Server, and I have a test database. And let me refresh the tables, and you're going to see that there are no tables there. So there are no tables, right? Okay. Now go back to perfmon, and I'm going to start this. All right, so now let the data collector run for a little bit. Just a few seconds. I do refresh. And my tables show up. So I get 3 tables. And let's take a quick look at what's in these tables. So the first table has the list of the counters. So 1 row per counter. I have a counter ID and a counter name. You see, these are all the counters that I just picked. The second table has 1 row per counter per measurement. In this case, it's per second. So record index is the first, shows you the measurement number. So this is the first measurement. First, second, we have 12 counters, and these are their values. So it's a very simple model. And this last one just gives you the name of the data collector, which we're not going to look at right now. So having this data model is very easy to store information and pull it into a Power BI report. Now, if you look here, I have another data collector running that has the set of counters I want, and it's writing to my performance monitoring database, which is where I'm going to pull all information. So perfmon data is right now going into here, and I'm going to pull in data from other places too. So I have counter data, counter details, and display to ID coming from perfmon. All right. Now, I'm going to show you what that table looks like in Power BI desktop. So I go to my Power BI desktop. This was the last view from earlier today. So this is the kind of thing we're trying to get to. So I'm going to hit refresh. Let's take a look at what it's been recording. So this one shows where we were running that query, right? So this is showing you analysis services, CPU usage versus the box usage. Currently, the price of memory is 0, and you can see we had a spike. This is the same spike that we saw in Excel showing up here as same thing as the price of memory. And if I look at my data model, you'll see that it's very simple. So I got the perfmon data and the counters. They're connected from counter ID to counter ID. And then I've also created these 2 tables, a date table and a time table. And I am connecting them on the respective columns. On the perfmon data, so if I go from here and open up my perfmon data table, I've created a bunch of measures. So not only I can get the counter value, right, but I've also created a bunch of measures, and I've created them very simply by going through the wizard. So even if you don't know how to write DAX, you can use the wizard to generate this for you. And all of the counters have the same format. So all of them, I'm getting the value of the counter value, and I'm filtering the counter name to one of the counters. So I want to look at one of the counters, and then I'm dividing by 1024 to convert to megabytes because I want to look at everything in megabytes. Okay, so now that I have all of these built in here, it's just a matter of adding them to visuals and I get my dashboard going. So I can also pick one particular counter and I can see how that one particular metric's been doing. So I have available megabytes. We had a dip here. I have another view where I can compare two different counters together, megabytes compared to how much NL services memory took. So you see as NL services went up, the amount of memory on the box went down. So you'll be looking for anomalies. So sometimes maybe NL services memory didn't go up, but something else ate the memory and put pressure on analysis services. So you want to look for scenarios like that, and that's what this would be useful. And then finally, from the memory, it's the same graph that I had in the first page, right? So up to here, up to CPU, everything's coming from perfmon. But I also, if you look here, I have information about traces and sessions that are running. I have information about memory usage, who's taking the most amount of memory, and about queries, the queries that have been running and against which database, the average time. So where are these coming from? So let's go and take a look at where we can get those. All right. So analysis services has what's called dynamic management views. If you connect to analysis services and you start a DMX query, then you can write these queries that look like SQL. It's not full syntax SQL, but it gives you a bunch of information about your server. So currently you can see that I have several sessions open, connected to different databases. I can also take a look at what traces are running. Now this is a dev box. That's why I've left the flight recorder run. Otherwise you don't want to see it. I just wanted to have something to show you. And then I can also search for memory usage to see who's using the most amount of memory from which database. And obviously everything here, the worst culprits here are coming from my 311 database. And there are columns like location, service request number. These are not compressible because they have very high cardinality. Okay, but how do I get these to my SQL database, right? The answer is I use a link server. So if I look under server objects, link servers, I have defined a link server to my analysis services server. And if I look at the properties, it's very easy to create. So if you click create a new one, you're going to see the same window as you see here. You give it a name for the provider. You pick the provider for analysis services. For the data source, you don't have to put a full connection string. You can just put the name of the server. And then the catalog, you only want to specify it if you're trying to fetch information from one particular database. So if you want to get a list of tables for that one particular database, certain DMVs work with the catalog. Otherwise, you don't even need to specify this, right? So now that I have my link server, if I expand it, I'm going to see the same databases that I saw up there, but notice I'm under my SQL server, right? So now I have my databases, and now if I go back to my SQL server, I can use an open query and my link server to access one of those DMVs. So now I have this in SQL, and I can even run DAX in SQL and get the results back here. Once I have this code, I put them inside views. So now I have views that are called traces, sessions, memory usage, and I can just query my views. Okay, so those last tabs in my Power BI report are pulling from the views. The only thing that's left for me to show you is the queries, because we want to also keep an eye on the duration of queries. How do I do that? I'm doing that by using extended events. So if you go to your analysis services, go under management, you're going to see extended events. And I don't have anything right now, so I'm going to start a new one. So I'm going to go to new session. I'm going to give it a name. Go to events. So for the purpose of what I'm trying to do, which is capture queries, the only event I'm looking for is query end. I'm going to add this. So if you ever work with SQL Server Profiler, which, by the way, is not dead for analysis services and has its own use cases still, you are familiar with most of the, you're going to be seeing familiar events here. So go to data storage. From here, I'm going to pick a file destination because I want the results to go to an XEL file. And let me grab my path. So I want my files to go here. Okay, so that's where I want my files to go. And I also want to, by the way, I also want to see the traffic live for the moment. So I choose event stream so I can see it in Management Studio. Click OK, and this is going to start the event. But once you have an extended event trace that you like, go ahead and script it, because the downside of the extended event traces for analysis services is that you cannot stop them, you cannot pause them. So that's the only reason I still use Profiler as sometimes, is because with Profiler, I can pause them, I can stop them, I can restart them. Here, you have to delete them and restart them. So I'm going to click OK. Now I have my trace. I have my session going. I can say watch live data. And I gave it the same name as the previous one. That's why this window popped up. But if I go back to my simple DAX, run it, go here, it's going to show up in a second. Or not. Okay, let's try this one more time. Let's try this. Okay, I don't want to close this right now because this is the newest version of Management Studio, and I've noticed there's a bug in there that if I close it, it may crash. So I don't want to do that. So how about we do this? So let's start a new one with a new name that I haven't created before. Okay, let's do this again. Query end. Okay, data storage. Let's pick a file. And I think I still have the path here. Okay. And let's live stream it too. Okay. All right, now let's watch this one. Okay. And then go to the DAX, run this, come back here. Okay, here it shows. All right, so now I get the event showing up here, and I can see how much CPU it used, what was the duration in milliseconds. Now, this is also writing to an XEL file. So if I go back to the same path that I gave it, I'm going to see the file show up here. You see that 1, 2, 3. This is an XEL file. So it's writing the results to the XEL file. Now, the way I read the XEL file is by using some SQL code. And the code is the same code. So it may look scary, but it's always going to be the same thing, always almost the same format. So if I run this, so this is pointing to all XEL files in that directory, I get these XML nodes, and you can see that I'm going to parse this in a minute. So I can go to data to where the name is duration and fetch the value. Go where name is CPU and fetch the value, right? So in my other SQL, I'm running the same query that I just ran inside a CTE, and then from that, I go to certain nodes and I pick the value. And this, again, This looks scary, but regardless of what session you're running, you can reuse this code. So you just got to change if the things here you don't want, you just take them out or you change the names. And once you have this code working one time, you can get it to work always. And that code is sitting inside a view for me. So now I get a list of my queries in SQL and when they start, when they end. So that gives me all the query stats as well, which are showing up here. Now I wanted to show you real quick the memory usage tab because I went over that one a bit faster. Here, I'm using this heat map to tell me which object or parent object is taking the most amount. So the parent object here is one of my tables. So it's telling me that graffiti, which is the one that had about 1 million rows, is taking 200 megs of memory. And if I click on it, within that, it's going to tell me, okay, which columns are the biggest contributors to that that size. Now, this view from, if you're a developer, hopefully you know this because you deployed the database, but if you are an admin, this is useful for you to go and look if you have memory pressure to figure out, okay, if you cannot increase memory, you can go and work with your developers and work with the team that has the biggest consumption and with them be able to focus on certain parts of their work and tell them, okay, this is what you need to work on. You can, how about we work on this column, this column, this column. This way you can get that kind of information. So I just showed you how I can pull information from perfmon, DMVs, and extended events into a SQL table, store it, and once it's in a SQL table, what better tool out there to build a dashboard than Power BI desktop. I'm going to put my slides back on, and at the end of it, I have some references listed for you if you want to read more. Here's my contact information. Thank you so much for joining, and let's see if there are any questions.
There are no questions.
Okay.
Maybe some will pop up now, so it's your last chance to ask questions.